All right, today is Graphing Trig Day 2. And what we're going to talk about today are adjusting the period and the lateral shift. Lateral shift. Okay, yesterday we talked about the general equation for graphing sine or cosine. I'm going to write just sine, but remember it's also including cosine. Y equals A times sine of B times the quantity x minus C plus D. And yesterday we learned how A affects the amplitude and D was the vertical shift or the V shift. But today we're going to be looking at B and C. Now, B changes the period. And for sine and cosine, it's always going to be 2 pi divided by B. 2 pi divided by B. That's what our new period is going to be. And then C changes the lateral shift. That's the left and right. Left and right movement, where vertical shift was up and down. Guys, it's no different than what we did with parabolas, any graphing thing. X minus H plus K, remember that stuff? C is just like H. It moves the opposite way of what you think, whereas D goes and moves it up and down, and it moves it the way that you would expect. All right, so let's do a couple of examples here. First of all, let's just affect the period first. We got Y equals 3 times the sine of 2x. Let's just hook this one up. Okay, so the period of this graph, normally it takes, think of the unit circle. Normally, oh, that's the worst unit circle ever. Get to erase, oh, there it is. Normally, it takes 2 pi, that's not even any better. It takes 2 pi to go around. But this time it's saying 2 times whatever x is. What it's saying is this is going to go around the unit circle 2 times as fast. So while it's going around twice as fast, that means it's going to shorten the period. And I'll show you that in just a minute. Remember, period is 2 pi divided by b. In this case, b is 2. So 2 pi divided by 2 is 1 pi. And that brings us to our interval. Our interval. Now, yesterday when we were graphing these, we made 4 tick marks, right? And yesterday the 4th tick mark was 2 pi, but today it is not 2 pi. Today the last tick mark is pi. So if the 4th tick mark is pi, because that's our period, what is the interval for each one? Well, pi divided by 4 is, each one's going to be 1/4 of pi. All right, and we'll label these later, but first of all, let's go back to here. Let's talk about the amplitude. The amplitude here is 3. And then we're also going to add a couple of other things. Let's talk about the lateral shifts. Is there any movement left or right? Remember, it's x minus c. The c is inside parentheses. There's no parentheses. So here there's none. And we talked about the vertical shift. And that's if we're adding something outside the parentheses. There's nothing being added here. Thus, it's none as well. All right. So catch up writing that stuff down. And then draw your coordinate plane. And we're going to have 4 tick marks, both in the positive x-axis and the negative x-axis. And we said that the interval is pi fourth. So this is 1 pi fourth, 2 pi fourths, so this is pi halves, 3 pi fourths, and then pi. And then the same thing going negative. I'm only going to put up the negative pi here. Okay, let's start with the amplitude. The amplitude of this is 3. So we're going to go up 1, 2, 3. Make sure you got room to deal with this amplitude. However, we're starting with sine. Sine graph on the unit circle, remember 0 degrees. What is the sine value of 0 degrees? Well, the sine value, this is be the point, 1, 0. Sine starts at 0. Then it goes up 3 because the amplitude. Goes up to 3. Then it starts falling back down back to 0. Continues to fall back down until it hits -3 in this case. And then goes back up to 0. And then follow that pattern backwards. 0, bottom, 0, top. 0, bottom. 0, top. 0. And normally I'd have you just draw a dotted line here. But because we're not shifting this at all, we can just draw a solid line like this. So there is a graph where the period has changed. Now I know what you're thinking. Mr. Smith, that looks exactly like the same graphs that we did yesterday. You're telling me that the graphs that we did yesterday looks the same way. We changed the period, it looks the same. The only reason why it looks the same is the way we scaled it. The ability to scale is what separates us from the animals. And so yeah, while it looks the same, it makes it easy to graph. We just know that this is actually a smaller scale. Awesome. No, number 2. Y equals the cosine of x divided by 3. Now, while we're thinking about this, copy that down and let's write the same things. Let's talk about the period. Let's talk about the interval. Let's talk about the amplitude, the L shift, and the V shift. We're going to talk about all these same things. Now, one thing we might want to do is rewrite this. What's another way to write cosine of x divided by 3, but such that we have a multiplier in front of x? This would be cosine times 1/3 of x, or x is in parentheses. So the period is going to be 2 pi divided by b. What is b here? Well, b is 1/3. Oops. Oh, snap, Smith, you gave us a fraction. What's 2 pi divided by another fraction 1/3? Indeed, it would be 6 pi. Now, what does that mean? A period of 6 pi means it's going to do one complete cycle, but it's going to take 6 pi to do it. Normally, it takes 2 pi. But remember, this 1/3 says we're going around the circle. 1/3 is fast. We're going to go slower. That's why it takes 6 pi to go all the way around it. So if 6 pi is the period, divide that by 4. The interval is 6 pi fourths, which reduces to 3 pi halves. Amplitude. What's the amplitude? Well, there's nothing in front. There's no a, thus it is 1. And then once again we got no lateral shift and no vertical shift. That's right, that's coming up next. But let's graph this bad boy. You might have an idea of what this is going to look like. It's going to look like every other graph that we've graphed. Just the important thing is the scale. All right, so 4 tick marks on the positive x and negative x axes. Our amplitude is 1. So all I need is 1 like this. Now, I'm not going to shift it, so I'm fine here. I don't have to plan ahead for that. But we are graphing a cosine graph. And on the unit circle, starting at 0, what does cosine start out as? Cosine starts out as 1. So up here at 1. Then watch what happens as we go around the unit circle. What happens to our x values? They get smaller until it gets to 0. Then what happens? It continues to get smaller until it gets down to -1. Then as it goes around here, x values start to climb again up to 0. Remember, we're talking about the x-axis. And then it would climb again up to 1. And that is 1 cosine. Oh, snap! I didn't label my axes. The period is 6 pi. Here's 6 pi. So this is 0. All the way to 6 pi. This is 3 pi. And like we said, the interval is 3 pi halves. Oops. So 3 pi halves, 6 pi halves, 9 pi halves, and then 12 pi halves would be 6. Going this way as well, -6 pi, -3 pi. Should have done that first. My bad. Okay, so then, making another cycle going the other way, this is following the same pattern. Top, middle, bottom, middle, top, middle, bottom, middle, top. Now, again, because we're not shifting, we can just make a solid line through it. Awesome. Looks like a W. All right, let's put all of this mess together. All together now. Let's go with, how nasty I want to make it. We're going to do this one. Y equals -2 cosine, parentheses, 1/2 x plus pi, just like that. We'll just do this. All right, now, if you recall from the front, the general equation y equals a times sine or cosine. Well, in fact, here, for this case, let's go with cosine. A times the cosine of b, then it was parentheses, x minus c plus d. How is this different than this? Here, the coefficient in front of x is 1 because b is outside. So let's change this so it's in this form where b is outside of the parentheses. In this case, that would be -2 times the cosine. We're going to factor out the leading coefficient, which is 1/2. And what's going to be left inside the parentheses? Well, it's going to be x plus, then it would be pi divided by 1/2. What's pi divided by 1/2? It would be 2 pi. Now, some of you, that might freak you out for a second, but oh, there it is. You just got it. Check yourself. What if I was to distribute it back? Could I get back here? That would be 1/2 x. 1/2 times 2 is pi. See how they are the same. All right, so that makes, start off with the period, the interval, the amplitude, the L shift, and the V shift. Those are the 5 important things before we start graphing. So the period is 2 pi divided by 1/2, which is indeed 4 pi. That means the interval would be 4 pi divided by 4, which is pi. The amplitude is, now the number in front is -2, but remember, the amplitude is always positive. So the amplitude is 2. The lateral shift, that's the left and right shift. This is going to go, now which way is this going to go, left or right? It's going to go left, 2 pi. And the vertical shift is none. Oh, snap. I'm going to go ahead and graph this yourself. I'm going to pause it. When it comes back, you'll see the graph. So go ahead and pause this, graph it, and check yourself. All right, so your final graph should be the red graph. The first graph, I took care of the period and amplitude. That's the purple dotted graph. Now, notice how it starts down here at -2. Remember, a was -2. Cosine normally starts at 1, but because times -2, it's down here. Then each one shifts 2 pi left So each piece went